Welcome, everybody, and thank you for attending today's Parasoft presentation on what's new in our latest release of CC++ test version 2020.2. My name is Ricardo Camacho, and I'm a technical marketing manager for Parasoft. And I'm also accompanied by product manager Miroslav Zielinski. Say hi, Miroslav.
Hello, everyone. It's a pleasure to be here today.
Awesome. Anyways, Miroslav is going to be presenting some of these new features and will be giving us a live demo of C++ test in action. So it's going to be very exciting stuff. Now, before we get started, let's go through some housekeeping. Let me see if it's switch here. It always takes a little while to take control of this slide. There we go. First, now everybody's microphone has been muted. However, if you have questions, please enter them into the Q&A dialog that you'll see. Also, if you run into any technical problems, like not being able to hear audio during the presentation, please use the chat or Q&A. There, you can also connect with one of our team members who is ready to respond. Also, this presentation is being recorded and will be made available typically within 24 hours. Okay, so let's get ready to start here. Let's go to the next slide, the agenda. Now, I'm going to start with a very quick introduction to Parasoft. Some of you may be new to us, so I want to make sure that you know who we are and what CC++ test is all about. I will then pass the baton over to Miroslav, where he will jump into what's new in the 2020.2 release. And Miroslav will start with the static analysis feature enhancements and upgrades. Most important, we want to make sure you walk away with the value that they provide. So Miroslav is going to deliver a live demo, and you will find that we are in a that these demos are actually very informative, and they're always a treat to watch. I'm then going to be tagged back where I'll be touching on some of the additional features and enhancements in this release, and then we'll finish it up with Q&A. All right, so let's get started. Now, Parasoft has been in the software industry for over 33 years, leading the industry in automated software testing, with a strong focus on offering the solutions needed by software companies in achieving standards compliance for safety and security critical systems. Now, our headquarters is located in Los Angeles, California, and we have various offices around the world. So no matter where you are located, there is a Parasoft representative in your time zone, willing and able to accommodate any requests that you may have. Also, we have a very broad product portfolio covering everything from a comprehensive set of static analysis solutions to unit testing and other testing methods, on up all the way through to not just in the embedded space, but also in the IT enterprise space. And actually, this puts Parasoft in a very unique and advantageous position worth knowing a little bit about. So I will quickly talk about both of these software testing domains, but the focus for this presentation is embedded. Now, another key point is that all of our Parasoft products in our portfolio are built by Parasoft. They are not acquired products, therefore the integrations between them are seamless. Now, this slide gives you a visual of the software domains and enterprise IT and the industries that Parasoft supports. You can see the automotive, mil-aero, rail, medical, and industrial automation for the embedded space. And we also support financial or banking services, healthcare and insurance, and other IT industries. You will notice that there is some overlap between the two domains or circles, which again makes us unique in being able to support your embedded development as well as your back office applications. However, this presentation again is focused on the embedded side. So let's take a closer look at our unified solutions. Now, for embedded, our customers are generally trying to satisfy their industry compliance requirements. Standards such as automotive ISO 26262, avionics, DO-178B or C, medical, IC 62304, rail, EN 50128, and industrial automation, IEC 61508. Now, Parasoft provides the testing methods defined in these process standards. Testing methods like static code analysis, which we support MISRA, AUTOSAR, CERT, CWE, and many other coding standards, or you can build your own custom in-house coding standard. We also automate your unit integration and system testing, help users perform structural code coverage, statement, branch, MCDC, and assembly or object code, and other types of testing, which some of them fall in the IT space, like API testing, UI testing, and service virtualization. Also, very important to know is that we easily integrate with your embedded ecosystem. So within it, we support lots of toolchain solutions. We help you test on your host, virtual, or target hardware. We support an extensive list of compilers, and we integrate with numerous IDEs. And you'll see some of this information that we've added also to this release that we've just come out with. Now, IDEs like we support IDEs like Eclipse, VS Code, Code Composer, Wind River Workbench, Green Hills Multi, and the list actually just continues to go on. Also, we support the coding languages C, C++, C Sharp, Java, and .NET. And there are other testing methods supported like UI testing, API testing, and more. Now, in embedded, I'm sure you're all familiar with the software lifecycle V model. So to help facilitate and put this in an infographic, we have mapped our solution within that development phases of the V model. So starting on the left side of the V, you have ALM or requirement management tools like Codebeamer, Polarian, and a Java integration is being developed actually right now. So the left side is where requirements management and requirements decomposition is performed. Parasoft DTP is where the handshake and exchange of information takes place between these tools, because requirements traceability to test cases is key. Now, on the right-hand side of the V, you have all of the testing solutions offered by Parasoft for each of the phases. And as you can see, our solutions complement each other, addressing the right and the left side or end-to-end verification requirements recommended or mandated by industry standards, specifically for safety and security critical applications. Extremely important is that the automation delivered by Parasoft solutions improve productivity, they reduce effort, labor cost, and they shorten the time to market. Now, one final bit of information is that Parasoft solutions are TÜV certified for use on safety critical applications, and Parasoft has a tool qualification kit available for meeting standards like DO-178B and DO-178C and so on. Now, okay, I think you've gotten a good foundation to build from. So I'm going to now pass control over to Miroslav, where he's going to start us off with what's new. All right, Mirek.
Thank you, Ricardo, for this great introduction. So our webinar today is focused on the new features introduced in C++ Test 2020.2 release. But before I dive into discussing our novelties from the latest release, I would like to start with a quick high-level overview of entire 2020. With our products, we were active around three main themes. We see that the development environments are constantly evolving. So one of our primary goals was enhancing integrations with agile workflows and modern development environments. Our focus was on Docker containers, CI/CD, Git-based development workflows, and popular code development tools like VS Code. The second important area for us was enabling complete and continuous support for safety and security coding standards. Following the language evolution, we have enhanced our support for modern C++. We enhanced the static analysis checkers accuracy for AutoZAR, MISRA, CERT, and other coding standards. And in our previous release, we have introduced a very innovative technology based on AI and machine learning to automatically prioritize static analysis violations. This functionality boosts the productivity of the teams striving to achieve compliance with coding standards. And finally, our third focus was on reducing the cost of creating and maintaining unit tests, but also on the traceability reporting and code coverage monitoring. In our previous release, we added an innovative technology called Coverage Advisor that uses deep static code analysis to compute inputs for new unit test cases required to penetrate sections of code uncovered with existing test cases. We added integrations with CMake-based builds. We introduced integrations with CodeBeamer, Polarion, and Jira. And in our latest release, we introduced the ability to monitor all types of code coverage metrics via Parasoft DTP. There is also a collection of enhancements to the requirements view, which facilitates requirements-driven unit test creation. So this is a high-level overview of entire 2020. Now, let me walk you through the most interesting enhancements from our latest release. And the first thing I want to share with you is our enhancements for the static analysis integration with modern development workflows. So let me start with highlighting what are the expectations now for modern static analysis tool. With large and complex code bases, teams expect static analysis to be tightly integrated with CI/CD pipelines, to be focused on their daily work, meaning to return quick feedback without long delays, and also to be able to filter out pre-existing or irrelevant problems and present only violations correlated with the most recent code edits, and also enable effective suppressions or waivers management. The popular picture we frequently see among our customers is a Git-based development environment with a dynamic approach to branching and merging. Developers frequently create feature branches, develop in the feature branch, test, and merge back to the stable stream. These feature branches live sometimes only a day or a couple of days, sometimes several weeks. And teams expect static analysis to seamlessly integrate into these workflows. And there are several phases in these workflows which are challenging. Static analysis performed in the feature branch as the code is created. The main challenge here is the speed of analysis and focus on relevant problems only. Developers expect feedback as soon as possible when the code is still fresh in their memory, and it's inexpensive to fix. And the feedback should include findings relevant to their recent code modifications. Developers don't want to wait a long time for results and waste time analyzing pre-existing problems or violations coming from other files outside of the scope of their modifications. In this phase of the workflow, the speed of analysis is favored over the accuracy. The idea is basically to eliminate as many static analysis findings as possible in the newly added code without delays that hamper the productivity. In the next step, pre-cleaned code is committed, and commit triggers CI/CD pipeline. Here, the static analysis is executed together with the build, probably on a powerful server. In this phase, static analysis is configured to favor accuracy. Obviously, speed is always important, but in this phase, we want to catch this few remaining violations that were not detected during the local scans in a future branch due to speed-related restrictions. And finally, delivering feedback from complete CI/CD scans back to developers. In this phase, the goal is to simply enable developers with the relevant information to fix these additional problems that were detected in complete extensive CI/CD scans. Developers want to fix remaining problems and merge their feature branch. They can access these findings using web-based interface, or preferably have these results delivered directly to their IDE. So now let me share with you some more details on how our new release enhances static analysis usage in this kind of workflows. And first, let's focus on the developer working locally with the feature branch. As we discussed, at this phase, speed of the static analysis is critical. Developers hate waiting for things to happen, including static analysis execution. Our enhanced Git integration can adapt the scope of the analysis to make it focus on the recent code modifications. How does it work? C++ test compares the current development branch with a parent branch or any specific commit pointed by a developer, and automatically computes the minimal set of files which should be included in the fast static analysis session. This set will include all files modified by developer, plus some additional files required for the successful static analysis execution. So instead of running the analysis on entire project, which may take significant time, even hours, we run it on a minimal set of files that are automatically selected by the tool based on the integration with Git. This approach's huge benefit is the speed of analysis and the fact that developer will receive violations that are most likely related to his or her newly added code. Obviously, some checkers require a system-level view to report accurate violations. These checkers may not be 100% correct in these restricted runs. We may experience some false positives or some false negatives, and that's why we recommend complete runs in the CI/CD to assure that we're not missing something. Okay, so to summarize, automatic scope restriction introduced in C++ test 2020.2 improves developer productivity by shortening feedback loops and focusing static analysis on recent code modifications. It's recommended, however, to combine these runs with unrestricted static analysis scans in the CI/CD. Our latest release brings one more functionality that helps in focusing static analysis on relevant problems. This is baselining of the static analysis results. It helps to distinguish new static analysis violations from pre-existing, which is frequently a huge pain for teams working with, for example, legacy and compliant code, or other example could be converting quick prototypes to compliant products. When running the analysis on this kind of code base, which was not created and not maintained in compliant state, developers will see all the violations, the ones caused by their most recent code modifications and those that exist in the code base for a long time. And these pre-existing findings, in many situations, are not a current concern for teams, and they hamper productivity. Teams know that the code will eventually need to be cleaned, but this is not their primary goal at a given point of time. They want to simply make sure that they are not increasing, that they are not adding new problems, and they are not increasing the compliance debt. And this is where our latest release with results baselining feature helps. How does it work? With C++ test 2020.2, when running the static analysis, users can provide a reference report representing the project's accepted state. When the new session is executed, results will be compared with those pre-existing, and only new findings will be reported. So instead of seeing tens or even hundreds of pre-existing violations, developers will be able to focus on those 3, for example, that are caused by the most recent code modification, which is a huge productivity improvement. So to summarize, result baselining helps in introducing zero new violations policy, controlling compliance debt, and improving developers' productivity by eliminating tedious reviews. This functionality can be used separately or together with already discussed automatic scope restriction based on the Git integration. Now, let's move forward to the CI/CD phase where extensive scans are executed and see what happens with these additional violations that are caught at this stage of the workflow. As we discussed, pre-clean code is pushed to repository, what triggers these CI/CD scans, which may reveal additional static analysis findings. These additional results need to be made available to developers. And there are many options to share these results. One of the possibilities is to send them to Parasoft DTP, a web-based platform for results aggregation, triaging, and advanced analytics. Developers can then either use DTP web-based interface for viewing the results or download them directly to their IDE. And based on our experience, many teams prefer this second option because then results are accessible via the interface that developers use most of the time, their preferred IDE. And our latest release enhances Parasoft extension for trendy Visual Studio Code to enable static analysis results download from Parasoft DTP. This is a functionality that was already available in our plugins for Eclipse and regular Visual Studio. Now we added it also for Visual Studio Code. How does it work? Well, simply developers can connect to the DTP server directly from the VS Code through the Parasoft VS Code extension and request results for selected project. After download, results are available in the VS Code the same way as they would be generated in the local scan. And developers can immediately start remediating the problems. And now let me move to the last static analysis related subject and discuss some new options that we have added for managing suppressions. All right, so any team serious about static analysis understands that suppressions or waivers management is critical to use static analysis successfully. So far, Parasoft users could store suppressions information directly in the source code in the form of code comments or use an external database, Parasoft DTP or Parasoft DCM. And storing suppressions information in the code in the form of the comments is probably the most effective way of managing these exceptions. But many teams are not allowed to do so, especially when the code is going to be delivered to an external contractor who may be using different static analysis tool, or simply there is an internal policy which forbids adding tool-related comments directly to the source code. To help teams manage their suppressions together with the source code without quote polluting the code, we have introduced a new way of suppressing static analysis violations. How does it work? New suppressions are stored in a plain text files. There is one suppression file per source code folder. The default name for this suppression files is parasoft.suppress. And our tools are pre-configured to include these files in the analysis as a source of suppression information. And there is no additional configuration required to enable this functionality. Users can add new suppression entries to Parasoft.suppress files, either by using dedicated user interface action or by adding these entries manually, since these are basically plain text files. And suppression files are intended to be stored in the source control together with the source code. So if a new suppression is added or existing suppression is removed or any other edit is done to this file, modified suppression file shall be committed into source control, and the team will be able to review it as a part of their regular code review process. When a new branch is created, suppression information will be a part of it. And similarly, when a branch is merged back to the stable stream, suppression files will be a part of this process as well. So with this approach, teams have control over suppressions and full visibility into the suppressions management process. Nothing is hidden in external databases. Sharing suppressions become natural. It follows the same path as the source code, and the source code does not need to be modified. Plain and simple. And This concludes the first part of our presentation. Now I'd like to do a quick demonstration to visualize our discussion so far. Then I will pass to Ricardo to share some more information about our latest release. And in the demonstration part, we're going to see three things. How enhanced Git integration helps in shortening and focusing the static analysis runs. How results baselining helps in eliminating pre-existing violations. And finally, how enhanced Parasoft extension for Visual Studio Code enable developers to access CI/CD results. So let me stop presentation now. And let me switch to the demonstration. So what you can see is the Visual Studio Code editor with C++ test static analysis extension. I'm a developer working locally at my desktop. I'm just about to start working on a new feature. My first step is to create a feature branch. So let me go here. Let me create ESP, for example. Once my feature branch is ready, I can start implementing the new functionality. So let's pretend we're doing something useful. Some quick example. Okay, I'm done with a small increment, so I'm ready to commit to my feature branch. Here we have a trivial example. Normally, I would probably edit a couple of files. Okay, so my code is committed, and now I want to run static analysis to make sure I did not introduce any new problems. My goal is to be, so let me start static analysis with C++ test. My goal is to be MISRA C 2012 compliant. I'm working with legacy code that was not developed for compliance. So I'm running my scan. Takes a minute. And soon we will see results reported to the problems view. Okay, analysis has finished, and I have almost 500 problems for my code. So I'm not happy. First thing is that the analysis took considerable time. Second thing is that I modified one file or just a couple of files, and I got results from entire project. Obviously, for trivial examples, I could probably manually select modified files, but this is not something that could work for a real-world example. So what I can do is I can take advantage of the new Git integration feature and configure my local scan to automatically compare my feature branch with a reference point, which for me is master. So I can do it by these two simple options, and I'm ready to run analysis one more time. So now again, the project is scanned, but now the Git integration feature automatically compare my current feature branch with my reference point, and automatically focuses the analysis on modified files only. So analysis has finished, and now I can see I have results returned for the file I edited, which is good. I'm happy now. But the problem is that still I see a lot of violations that that refer to the code that I didn't touch. I know I will need to clean them at some point, but right now my goal is just to make sure I'm not introducing any new problems. So to help me with it, I can enable another new functionality that 2020.2 brings, results baselining. In my workspace, I already have report file generated by a previous scan on this code base from the phase which represents accepted state of my project. So that's my team intention is to have 0 new violations as compared to this point. So I enable this functionality and I'm going to run analysis one more time. Now in this run, in addition to Git integration, which automatically zoom in to the modified files only, I'm also using a reference report, which represents the accepted state of the project. And I'm expecting to see violations that are relevant for the new code I added. And that's exactly what I got now. Instead of these 400 violations in the first run and 20 in a second run, now I see only 4 problems that are relevant for newly added code. So I'm almost 100% happy. My only concern now is that with these restricted runs, I may be missing some problems. So I want to complement these local scans that are configured to favor speed of analysis with scans in CI/CD that are intended to do the complete analysis. And my project is hosted on a GitHub. It's configured to execute CI/CD pipeline using GitHub runners. So I will modify my YAML file, which defines my CI/CD pipeline, to run static analysis on my branch. So I need to enter here the name of my branch. Saving this modification, and now I need to commit it. I need to commit it, and I need to push it to my central repository. Yes, I want to create upstream branch. So my modification, my changes from the feature branch are pushed now to the central repository, and as you can see, this is already reflected in the GitHub. And here in the actions view, I see that my commit triggered the CI/CD pipeline. And here the static analysis is executed now. And here we have no restrictions. We want to analyze entire project. We want to make sure we are not introducing any additional violations because of these modifications for feature implementation. So complete scan is executed now, and my static analysis scan is configured to send results to Parasoft DTP. So the results will be uploaded just after the run is finished. And as a developer, I can access them in the most convenient way for me directly from the VS Code. So I can remove existing violations, and I can use the new functionality and import results from DTP directly to the VS Code. So now I have a complete picture without the need to run analysis locally. I can review and fix these additional problems that might have been caused by my code modifications. And this concludes the demonstration. Now I will switch back to the slide deck and pass to Ricardo.
Well, thank you, Miroslav. That was very educational, and it just demonstrates how easy to use and powerful our solutions are. Anyways, I'm going to start with also covering some new enhancements and some of the ones that actually have had a very strong positive impact towards static analysis and performance. So, for example, I'm going to click here at the next slide. There we go. Now, as the C++ language continues to evolve and users adopt the latest editions of the language for their projects, parsing errors due to gaps in support of these modern C++ language features occur, which can block users in their testing efforts. So Parasoft is always trying to stay ahead and ensure support of the evolution of the languages such as C++. So we have updated our parser, which includes complete support for C++ 17 and provides the majority of C++ 20 features. This enhancement eliminates known parsing problems, which prevent the successful execution of the static analysis sessions and code coverage instrumentation. Still having problems clicking on the next slide. Maybe Mary, if you can go. Yeah, thank you. Now, as a result of this language enhancement, we are also able to update many of the AutoSAR C++ rules, which provides a lot more accuracy and reduction in noise. Some Parasoft C++ test static analysis rules were created a long time ago, and they were not fully compliant with the latest evolution of the C++ language. Now, there's been a noticeable reduction in noise or false alarms in analysis reports, which prevents unnecessary investigative efforts, and therefore it also increases productivity. Now, some of the productivity gains have also been around performance. Performing static analysis sessions, particularly on modern C++, can be very time-consuming, especially when flow analysis rules are enabled on large code bases. Parasoft has also made a number of performance improvements to our flow analysis engine, so expect to experience up to 30% reduction in the analysis duration cycle. There has also been a reduction of up to 5 times in the size of generated temporary data captured in analysis caches. Now, this simplifies the integration into automated CI/CD pipelines with smaller workspaces. Come on, there we go. So there have also been some enhancements that improve our unit testing and requirements traceability. So let's go ahead and start covering some of that. Now, Parasoft C Test 2020.2 has further enhanced the automated import and export operations between ALM tools or requirements management tools like Polarian, Codebeamer, and I'm going to include JAMA because, again, we are working on an integration which will be coming out soon. Anyways, we have simplified the usability to ensuring traceability. There is no longer a need to perform a manual import of requirements. This has been fully automated. The integrations are configured in one central place, and that is Parasoft DTP. That's the blue bubble, the blue circle in the middle. Now, DTP is the hub for synchronization between the requirements in the ALM tools and the test case that are implemented in C++ test. So that's the green circle you see at the bottom. So the requirements can flow into C++ test where the user will have visibility and can create the test cases based on those requirements. After the C++ test user links the test cases to the requirements and executes them, DTP will export all this data. the traceability, the test results, and test runs into the ALM tool where they originated from the requirements. Now, where the full requirements traceability matrix is going to also reside. Again, that's the originating. It's going to have all the information in the ALM tool, so it's going to be available there. But what's also really nice is that there is bidirectional traceability. So you can navigate from the ALM tools to Parasoft tools. So it's really, really nice. Now I have made actually several other webinars demoing this solution. So I recommend that you visit our website and go to our resources page where you can watch these other videos and get a really good understanding of this very powerful integration. Also, if you're not familiar with Parasoft DTP, its dashboard is just rich with analysis information and progress towards compliance and testing to requirements. This actually leads me to the next slide. Now, Parasoft, again, this particular release, 2020.2 and DTP now provides support for monitoring all 9 code coverage metrics, particularly MCDC, as it was only visible or available in the CC++ test. So now you have widgets in DTP that offer individual or summary information about the total collective coverage achieved. You can see each of these coverage metrics, statements, MCDC, branches, which is the same as decision coverage, and the rest down the line, as you can see in this image, including the trend chart on coverage overview. So you can see those trend diagrams there. Now, by the way, these widgets are active. Not only can you move them around, but you can open them and drill down into the code coverage details for each of these. Now, allowing users to monitor in greater detail code coverage progress and make well-versed decisions about risk and resource allocation. So really makes a lot of business sense there. And there's more. There's a few other things that I want to cover for this release. And to support the embedded applications, you need to have a comprehensive set of compilers and development environments supported. Parasoft has a long list, but we are always constantly expanding it. So we have added Clang 10, GCC 10, IAR 8.5, and ARM Clang 6.14. And what I recommend is you visit our websites for the full list so that you can see what all of the latest ecosystem development tool chains available that exist. All right, let's go to the last feature that I actually want to talk about. And that's Parasoft is previewing our new product installer of C, C++ Test Professional for Eclipse IDEs in the form of archive files, .zip and tar.gz. Now, what I mean by previewing is that we are giving customers a period of time, an option to get familiar with changes to the product installation. This installation change will be officially incorporated next year in our 2021.1 release. So what this installation change enables is an automated deployment and management of updates within our customer's environment. So IT departments of large organizations can now unpack the distribution, perform required scans, customize the content, zip the modified distribution, and integrate it into an automated infrastructure which can be easily rolled out to potentially thousands of users. So this is really sweet. Now, this also makes the installation better suited for cloud and containerized deployments. We're always, again, thinking of modern ways to support our customers. All right, so that kind of concludes what I want to talk about here, the new feature. So I'm going to open it up for questions and answers. But before we do that, I want to make sure you get information or notification about product releases, webinars, and other activities. So you can follow us on LinkedIn, Twitter, Facebook. You can also contact us via email at info@parasoft.com. And if you would like to try Parasoft, follow this link here, this QR bar, and link to us, which will take you to our website so you can register and try Parasoft. All right, I'm going to start with our first questions here. Let me go to our questions. Okay, for Miroslav, is automatic restriction of the static analysis scope supported for Git only? And do you plan to support other SEMs?
Yes, as I indicated during the presentation, right now this feature is available for Git. We're planning to extend this functionality to other SCMs in the next releases.
Okay, great. We have a second question here. How much shorter is the static analysis in scope restricted mode?
This is an excellent question, difficult to answer. It depends. When we are working with a large code base, which can take like 2 hours to do the full analysis, and in the feature branch we just touched 10 files, then this speed of analysis can bring a significant advantage. We may be talking about minutes as compared to 2 hours. Obviously, again, the results will be focused on modified files with some potential inaccuracies here. So these CI/CD scans are really recommended for completeness of the analysis.
Okay. We have another question here. Why do you have lower accuracy in the restricted mode? Can I make it up with more powerful server?
Okay, another good question. This difference in accuracy comes from this restricted scope. So, for example, some of the checkers, like MISRA checkers, they require system view. They require analysis execution on all the files from the project to report accurate results. Also, flow analysis to be able to simulate the complete paths in the software and eliminate false positives requires the system level view of the software. So in the restricted mode, when we are running analysis on 10, 20 files, this is why we have this room for some accuracies, some inaccuracies, and it cannot be compensated with additional processing power added to the analysis server.
Okay. And our next question is, do you plan to provide zip installers for Visual Studio plugin as well?
Yes, that's something that we have on our roadmap. Most likely, this is something that will be included in 21.1 release.
Okay. And I think we've kind of touched on this one, but for traceability reporting, are you going to support JAMA?
Yeah, that's in our plans for 21.1.
Okay. And another question here is for code coverage reporting in DTP, do you also support path coverage?
Yes, this coverage overview widgets, they support all the metrics that are supported by C++ test, including path coverage.
Okay. Let's seeing any more questions.
Well, let me check also here. This is answered. This is answered. I think we have one more question. Report.xml file to compare against. I'm not 100% sure about this question, but this functionality for results baselining requires reference report, and report.xml is the input to this feature. So that's basically the answer. Before you can use this functionality, you need to generate a report which represents accepted state of the project, and then use it for subsequent runs of the static analysis. Hopefully this answers the question.
Mm-hmm. Okay. Yeah, I have is MISRA 2012 for C99 supported? One of the questions I see here.
Well, MISRA C, I'm not sure about this question. MISRA C 2012 is fully supported.
Yeah, it's an older, so yeah, it should be supported. It is supported. Okay. I don't know if there's any other questions. I see some here that the demo actually answered some of the questions, so there was a never mind. I think if any other questions we can answer via email, so we can address those. But I think that this concludes our presentation. And I thank you very much for attending. And please visit our website, resources for future webinars that are coming up. We have some really exciting ones on our list. So thank you again for attending.
Thank you.